Hello, this is Geometry 10.4. We'll be talking about inscribed angles and inscribed polygons, but we're still talking about circles. So if you remember, a central angle in a circle is an angle whose vertex is at the center of a circle. So a different type of angle in a circle is an inscribed angle. So an inscribed angle has the vertex on the circle. Central angle has a vertex at the center. An inscribed angle has the vertex on the circle. So if I let this be A, B, C, all the points here, A, B, and C, are on the circle, but specifically angle ABC in the diagram, since the vertex of that angle is B and that's on the circle, that's an inscribed angle. And then arc AC right here lies between the sides or the segments, or I can even make those rays, ray BA and BC, of the inscribed angle. That's what's referred to as the intercepted arc. If something's intercepted, it's like contained within. So arc AC is the intercepted arc of the inscribed angle, of angle ABC. And just like we found the measure of an arc for a central angle, or vice versa, we could find the measure of an inscribed angle and its intercepted arc. So the measure of an arc, if you know the measure of the inscribed angle, let's just say the measure of this inscribed angle, ABC, is x degrees. Then for theorem 1010, the measure of the intercepted arc of an inscribed angle is twice the measure of the inscribed angle. So this would be 2x degrees. Or you could also say the measure of an inscribed angle is half the measure of its intercepted arc. So in the diagram, I said the measure of the intercepted arc is twice the measure of the inscribed angle, which it is, but in terms of the theorem, the way that it's written out is the measure of the inscribed angle is half the measure of its intercepted arc. So let's just say we know the measure of the arc, say that's 60 degrees for the measure of arc AC, and then the inscribed angle that intercepts that arc is angle ABC, so the measure of angle ABC would be half that, or 30 degrees. And if you understand theorem 1010, the measure of an inscribed angles theorem, then the inscribed angles of a circle theorem should make sense, because if you have two inscribed angles, or it could actually be more, of a circle and they intercept the same arc, then those two angles have to be congruent. So let's just say right here I have arc PQ and an inscribed angle intercepts that arc. So angle PTQ intercepts arc PQ. From theorem 1010, it has to be true that angle PTQ is half the measure of arc PQ. But if I have a second inscribed angle, angle PRQ, that intercepts the same arc, that angle PRQ would be half the intercepted arc. So angle PTQ and angle PRQ would have to be congruent. So again, these two inscribed angles intercept the same arc, then they would have to be congruent. If I were to go over a specific example, let's say that's arc PQ, the measure of that. PQ is 100 degrees. So this arc is 100 degrees. Then the measure of the inscribed angle PTQ would have to be half of that, 50 degrees. The measure of angle PRQ, another inscribed angle, would also have to be 50 degrees. Okay, the theorem states if two inscribed angles of a circle intercept the same arc, then they're congruent. But I could actually have more than that. So I could have another inscribed angle. Let's call this point S. PSQ is an inscribed angle. It intercepts arc PQ. It would have to be half that. So that would be 50 degrees as well. So it could be if two or more inscribed angles intercept the same arc, then they would all have to be congruent.